All right, first up is point density, and we can see an obvious difference in the density between Portland and some of the other big cities and the more rural areas out here in the interior of the county. But what we're going to do is make a formal assessment of that. And we are going to search for the tool point density. And that's under Spatial Analyst. And the input point feature is going to be the Cumberland feature to point. And I'm going to have no population field to start off. And this is just going to tell me how many points are there within a specified distance. And this is generating sort of random values. I'm going to say give me a 300 meter, I'm just rounding these, and then a 2.5 kilometer radius. And the area unit is going to be in square kilometers. So here we go. So we have no population field, output's going to my C drive, the cell size, so the raster resolution is 300 square meters, and the radius is 2,500 meters, or 2.5 kilometers. All right, and there is our value. And we can see here that we have definitely concentrated values here, but I find the default color ramp here is not very informative, so I'm going to change that. So again, this is a raster, which means we can classify it like so, and I want the method to be quantile, and that's going to give me something that is important here, a value of 0. And I'm going to actually change that value of 0 to no color, because there's no data for that, or that 0 is a meaningful difference from the rest of the data set, so I don't want to confuse it with another blue area. So out here, that's outside of the Cumberland County, that's in the middle of Sebago Lake, and that's in the Atlantic Ocean. But now we can see with the quantile set, and again, quantile means that there is an equal number of observations, meaning equal number of raster cells in each one of these 8 values. And we can see big concentrations here around the cities, and then concentrations around Sebago Lake. Now, let's run that tool again, and we can go back into the Results tab, and now I want a population field, and that population field is POP10, and that is the total number of people counted within that. And now I'm going to change that. That red X means that I have to change the name, and again, within 2.5 kilometers. Let's see how that changes things. I'm going to turn that one off and turn that back on. And again, we have more people where there are more census blocks. They sort of made it that way. So let's keep that and change that to quantile again. And again, that means equal numbers of raster cells in each one of these values. And there's that. So let's change this one to be completely white again. That didn't quite work. Let's go ahead and change that to no color. So yeah, so there are our 2 data sets. So this one where you have the population, and that one where you just have the density of census blocks. Slight differences. Not huge. So this is what you would actually consider to be an auto-correlated data set. So because they put more census blocks where more people are, in order to give an accurate count, I presume, the 2 data sets are related, so that's why you see a similar pattern. So it's really 2 different ways of measuring the same thing, which is how many people live here. If you had a rural area with nothing but farm field, you wouldn't chop it up into a bunch of tiny little census blocks, as you would if you were looking at downtown Portland. So you see here, these are all tiny little census blocks, and you have a lot of points, so higher point density. But then we have a huge number of people living here. So it makes sense to block this up into very small areas. So we can say, all right, 10,000 people live here and 8,000 people live here. We're going to provide a little bit more tax money here than here because more people are here to benefit from it, or whatever the case may be. but you need a smaller census block where you have more people. So the data set is autocorrelated, meaning it is correlated with itself. So I can't really compare these two data sets in a, this one's more than this one, because the one is really calculated from the other. They're both looking at population density in a slightly different way, but it's the same underlying process, if that makes sense. So that is how to run the